Okay, this is Anne-Marie Carrier from Herschel Jones.
Okay, I got it.
And you are here with me and several of my students, and we are going to review for our upcoming test over atoms and the periodic table. So let me go ahead, and I'm going to screen share with you the presentation that I've created for you guys. So welcome. Thanks for coming, and don't tell anyone it's a secret. You're going to get extra credit for being here because you're all awesome. Okay. So, can you tell me or type if you can see the PowerPoint? No, you can't see it?
So it's like flip-sided and stuff.
It's what, Jalen?
It's flip-sided, and I'm Joel. It's like
okay. Sorry, Joel, I couldn't hear you. Are you looking at it on your phone?
Yeah.
That might be why, because your phone's pretty little. So turn the phone sideways. Okay. So I'm going to go over some of this stuff, and we're going to go ahead and get started. Now today we're just going to review atoms in the periodic table and basic compounds. So next week what we'll review are the pure substances and the difference between atoms, compounds, mixtures, and elements. Okay, so that way we're not going to be here too long. Okay, there's some very interactive parts, so please feel free to jump in when you need to. All right. I had some difficulty in my test trying to put this full screen, so I am going to have to leave it like this. Okay, so let me know if you have some difficulty reading it. All right. So we talked about over the last couple of weeks that we know everything in the universe that we know of, Gavin, right, is made of atoms, and that's the atomic theory. Again, we talked about how a theory suggests that because what we already know to be true, or everything we already know to be true is made of atoms, that when we find other things, they'll also be made of atoms. But Gavin, you remember what we found in class, what everything else they suggest is made of? You want to say it out loud or you want to type it? Okay, in class with some of these guys, we found that some things they believe are made of dark matter, and matter is still atoms, right? But they can't see it, so they really haven't been able to prove what else things are made of. So make sure that you're aware that all atoms, no matter what kind of atoms they are going to be made of protons, neutrons, and electrons. Can y'all tell me which ones are in the nucleus?
Protons.
Okay, good. Emmanuel, and what else?
The neutrons.
All right, good. The neutrons. So again, we've used the term subatomic particles to review that. Just make sure you know that those particles are in the nucleus and none other. That leaves which particles to go around the outside?
Electrons.
Electrons.
Good.
Electron.
Good job. Can you see the diagram that I have on the screen?
Yeah.
Can anybody tell me what type of atom that might be?
A neutral one?
That would be a good guess. Well, how many electrons does it have?
I can't really count that.
8.
Okay. 8. Good, Gavin. So if it has 8 electrons, what might it be?
Ask the last question.
Oh wait, I'm looking at periodic table on Google.
Very resourceful.
So it's the columns, the groups that tell how many electrons it has?
Well, that's actually the valence electrons, which are in the outermost orbital or shell. It's the atomic number that tells us the number of actual electrons. So in this time, we only have...
Would that be oxygen?
It is oxygen. Very good, Emmanuel. So it's atomic number 8, and so that is oxygen. So remember that every element, which is our pure substance, the smallest amount of every element is an atom, is going to have a different number of these particles. Now, I just realized I didn't put in here, go over the charges. Cynthia, can you tell me what the charge on a proton is? Remember the P for proton? Oh, good. You got it on the screen. Okay, is P for positive. And then, Colin, do you remember about the neutrons?
Negative.
Not negative, even though the N for negative would be like neutron. But if it's neutron, it also has no charge, or it's called what, guys?
Neutral.
Neutral. Good.
Neutral.
Neutral. So if every atom has protons and neutrons in the nucleus, what's the charge of just the nucleus of an atom?
It usually would be a net neutral.
Well, the neutrons are neutral, but the protons are
Positive.
positive. So if you have positive particles and neutral particles, you're still going to wind up with what kind of number?
Positive.
Positive number. Good. So I want you to know that the nucleus of every atom is still going to have a positive charge. And it's the opposite charge between that nucleus and the particles that spin around it that will keep them drawn and attracted to each other. Okay?
Then,
right. We're going to
how do you have positive isotopes and like positive ions, or negative isotopes?
Well, and remember, I think you're using the vocabulary a little incorrectly. Remember the term ion is an overall atom that has a charge, positive or negative. And we haven't really covered that yet, but it just means that what's happening is, for some reason, the protons and the electrons are not the same number.
So if it has more electrons, it's negative, and if it has less electrons, it's positive?
If it has more electrons, it's negative. If it has less, it's positive. Yes, exactly right. Great job.
Yay.
Okay? And we'll be talking about that in one activity next week with your class. Okay? All right. So let's go ahead and move on. Now, we said that we can determine how many of these particles there are by the periodic table. And we learned these vocabulary words, which will be on your quiz tomorrow. So please, well, I guess this is a great review for you. So the atomic number in every box is going to be what? The bigger number or the smaller number?
Smaller.
Smaller number. Good. So here's the element krypton. Here's the element krypton. What? How many protons or electrons would it have then?
36.
36.
Good, exactly, 36. Now this has some other numbers over to the right on the side. Those are the electrons in its outer shell. And we didn't really cover that so much because our periodic table doesn't have these numbers here. Okay? But that's what those stand for any of you that were wondering. And so these are the orbitals. It has 2 in the first, 8, then 18, and then 8 in the fourth one. Orbital or energy shell. Okay?
Why does it have 18 in like the middle farthest, but then farther away where there's more space, it only has 8?
Because it didn't have any more. That's a good question. So it fills from the inside out. And remember how we said they have different strengths so that they can only carry a certain number of electrons, just like you could only carry a certain number of books?
Mm-hmm.
So after we got 2 and 8, that's 10. And then another 18 is 28, right? Mm-hmm. And it only has 36.
Oh, okay.
So it ran out of electrons. It didn't have anywhere else to put them. Or didn't need it anymore. So if it was going to be a neutral atom. All right. Now we said the atomic mass is the number of protons and the number of neutrons, right? And so those are in the nucleus. You can see them. Can you read my notes okay?
Mm-hmm.
All right. So that means the nucleus is positive. And I wanted you to remember that the rows on the periodic table tell us some of these properties of these elements, okay? So first, how many neutrons would there be in one? Yeah, I'm going to answer your question in 1 second, Emmanuel. How many neutrons are there in one atom of krypton? That's kind of like a big math for this time of night, huh?
I'm going to use my calculator.
Okay.
I have a telephone.
48.
48.
Good. We all got the answer at the same time. All right. So there are 48. And Jalen, would you mind telling everybody how you got that, please?
I subtracted the atomic mass to the atomic number.
Right. And, you know, I know that you guys are in upper level math, and so you're at the point where you're starting to subtract some bigger numbers from smaller numbers. But every time we do this, just know you're not going to come up with a negative number. And if you do, then you've mixed them up. So just always take the smaller number from the bigger number after you rounded it to a whole number. And whatever that number is the number of neutrons left in the nucleus. Okay? All right. So the rows on the periodic table that these elements can be found in are called the periods. And so that's where the periodic table got its name. And the energy, it tells you how many energy shells hold the electrons. So are any of you looking at a periodic table?
Yeah.
Yeah.
No.
Okay. So if you find krypton, what row is it in?
That it's an 18.
4.
It's in the 4th row, right? So if you look at this box on my PowerPoint, it has these electrons, 4 shells, and so because it's in row 4, you know it holds all its electrons in 4 shells. That's every element in that row has 4 shells. Every element in the 3rd row uses 3 energy shells or orbits to hold its electrons and so forth. Okay. I see you guys are leaving the group chat. Hopefully you're still with me and you're just not in the chat box anymore. All right. So same thing with the columns. We said that these are called groups, right? And the groups are what determine the valence electrons, Emmanuel. Okay. And that in this one, it's going to be only these 8. Is that what you were asking about?
Yeah, that's what I was wondering.
Right. The valence electrons are what are gonna determine the stability of the element. Okay. So we're gonna look real quick at the periodic table to go over some of these families. Did your screen change? Okay.
Huh?
You can see the periodic table.
Yes.
Mm-hmm.
Okay. All right, great. Well, when we take our test, it's important that you know the actual location of these families. This periodic table goes over many of them. It kind of excludes the metalloids, which we know are here, in between the metals and the nonmetals. And so just make sure that you know all the elements in the family have similar properties, right? So 2/3 of the periodic tables. Metals or nonmetals?
Metals.
Metals, right? All of these from this blue all the way over to the left are going to be metals with the exception of hydrogen. Remember, hydrogen is only here because it has 1 valence electron with all these other elements right here in this very first column. Okay? Now, this is our most reactive family right here. As you can see, it's the alkali metal. And then in the second family, we have earth metals, our transition metals. That's the largest group on the entire periodic table. And then over here, these are still some of our transition metals. This table has chosen to call it poor metals. Why do you think it calls them poor metals? Any idea?
Because they're not good at metals.
Because they're not good what?
Because they're not good at
metals. Okay, well, what are the properties of metals that it might be using as it turns into a nonmetal?
It gets dull. Doesn't sink in water.
Okay, you remember that from today? Well, remember, metals are good conductors, right? They're malleable and shiny, and they can be they're ductile, so they can be pulled into wires. So what I want you to know is as we go from left to right, because we're getting, yeah, conduction, good, Jolene, because we're going to the right, it's saying they're poor metals, but they start to lose some of these properties as we get to the metalloids and then the nonmetals and the noble gases over here. Because the things that have most of the metallic properties are going to be on the left side. So that's why they're transitioning. They start to lose some of their properties as they're in transition to metals. Okay, does that help? All right. So metalloids are this staircase here that kind of goes over the top of the light blue ones, tellurium and arsenic and silicon and boron. And those, remember, can have properties of metals or nonmetals. You don't need to know which ones have which properties as long as you understand they can be like both families. Okay?
So the
Yes.
poor metals would,
Yes.
like in our little periodic table thing that we colored and all that, would they be considered metals or non-metals?
These are still transition metals here. This table just says poor metals, and I wanted to discuss that a little bit, why it was calling that. Thanks, Emmanuel. Save some for me. But yeah, Gavin, they're going to still be transition metals. Everything to the left of the metalloids, which are here, Jalen, to answer your question, these are metalloids. So everything to the left are still metals, and we have different families of metals. This table just chose to describe them as poor metals. Did you have a question, Jalen?
Oh, yeah. Yeah, but you just answered it.
Okay. All right. On the right-hand side, these are all our non-metals, okay? We know that gases aren't metals, right? Like, hey, you got some metal jewelry, but it's a gas. Not happening. Right? Makes sense? It's logical? Okay. Maybe not. Anyone familiar with that? Do you remember why they're noble? The Storms family?
They're stable.
They're stable, good. And does anybody besides Gavin remember why they're stable?
No.
I do.
Okay, go ahead.
Because they have all of the protons in their outer shell.
Well, hopefully their protons in their outer shell, or they would have maybe exploded by now. What goes in the shells? Not the protons, but the
Electrons.
electrons. Very good. Very good. So yeah, they have all their electrons. Remember, these over here, the columns or the groups, tell us how many electrons in their outermost shell. These are very reactive because they have one valence electron. These right here, the alkali earth metals, have 2 valence electrons. Excuse me, these have 3, these have 4, but they have more energy shells because remember, that's the rows. Okay? Over here, these kind of, on this side, boron and carbon, they kind of jump this gap. So in this column, they still have 3, they have 4, they have 5.
The Mendeleev, is that why it's that big gap there? Is because of when he planned for there to be more, or did he just feel like drawing it?
That's a really good question. I don't think so, because what's happening is if they had planned for more to be here, like there would be here at the bottom of the periodic table, then the proton numbers, the atomic numbers, wouldn't continue from left to right. But down here, even though it's not on this periodic table like on yours, there were some blank boxes and spaces for one that is at 111, 112, and so forth.
On the one I'm looking, it has 118.
Right, that's what I was saying. Right now there are 118 elements known to man. Some are man-made, but it depends on the periodic table you look at. So obviously this one is not current.
There's a new noble gas.
Okay, what's that called?
Let me see if I can read this. Unocitium.
Unocidium.
So it's U and...
Right there.
Oh, good job.
Copy and paste.
Ununoctium. Ununoctium, maybe.
It has like a little apostrophe thing over the C or something, or like the I. The apostrophe I think.
Yeah, I think they just do that to confuse us in America.
Yep.
All right. So, all right. So let's keep going, okay? So here we have our noble gases. Does anybody remember what this family is that starts with fluorine, which is lacking one electron to be like the noble?
Halogen?
Very good. Halogen. Was that Cynthia?
No.
Okay.
I said it.
I can't.
Joel.
Sorry, I can't see who's talking when I'm looking at this. All right. Good job. So we're going to talk about the periodic table, but I'm going to take it off the screen to show you the questions, okay? So one thing that you need to know when we're looking at the periodic table, or as you're becoming familiar with it, is how the table is arranged. Okay? So from left to right, how
I'm back.
There are two of you.
I'm back, guys.
There's
There's two of you.
What?
Okay, that's creepy, but there are two of you.
Okay, is that Emmanuel?
I'm back. I got kicked out.
Okay, so let me eject that guy that's posing as you.
He's an imposter.
Okay. That's funny. So if we're in the middle of this, Gavin, can you turn your microphone off for a few minutes? So you know how your face keeps popping up? So, sorry, I was saying that if we're in the middle of this, first of all, it's broadcasting live. So anybody, anywhere can jump in and have something to say about what we're learning about. This is being broadcast to our YouTube channel. And so we can go back and look at it later if, say, like in a couple weeks before we go to take the test, you say, I remember we did that. What did Miss Carrier say? You can go back and watch this broadcast. And you can see if, you looked funny or not.
Where did Joe?
All right, Emmanuel, will you turn off your mic for just a minute?
Mm-hmm.
All right, thank you. All right, so we're going to go back. We're going to play a game in just a second, but I want to get through this last slide. So you can still see the periodic table patterns, right? Yes, okay, thanks for shaking your head. All right, game on, Jalen. All right, so if you'll type in the text box for me, how do you think the table is arranged? We know from left to right, it increases in what? I guess you could unmute your mic if you have an answer.
The number of protons.
Very good. Protons, and what is that, Jalen?
It's the number of protons in the nucleus.
Okay, very good. What tells us that on the periodic table?
The atomic number.
Very good, the atomic number. So as we go from left to right and then one row to the next, that number just continues increasing. Just like you said, Emmanuel, there's a new noble gas. It's all the way down. Is that number 118?
Yes, 118.
Okay, so that would be the largest of those numbers, and it's going to have the largest atomic mass, because you can see the next question is what happens to the mass as we go from top to bottom. Not only does the number of protons increase, but if the number of protons increase, and they're found where in the atom?
The nucleus?
In the nucleus, right? So that means that the atomic mass is also increasing, okay? All right, so of the protons, neutrons, electrons, which of those three do you think is most responsible for the reactivity?
Okay, so this is the second time I just
The
crashed.
electrons.
Good, is that Jolene? You were on it. That's exactly right. It is the electrons. So not only just the electrons, but pretty much those valence electrons, okay, in the outermost shell. So we're going to be looking at that further. All right, and so what about the reactivity then? How does that change from left to right on the periodic table? What do you think?
It gets less reactive.
Less reactive from left to right?
Yeah.
Cynthia, do you know what the most reactive family on the periodic table is?
The alkali metals.
Oh, see, I love that act you got going on there. That's right, Jolie. Cynthia's face was on the screen, and then your voice came through. Good job. All right, and so the alkali metals are the most reactive. It's all the way on the left. And so the least reactive, Colin, do you know what that is? No? Okay. Jalen?
Transition metal?
Nope, keep going. Keep transitioning.
Alkali metals.
Nope, that's going to be the second reactive. So when we're on the left,
Halogens. Halogens.
nope.
Noble gases.
Noble gases, yes. When you're on the left, the reactive, when you get all the way to the right, you are the least reactive and the most stable. Okay? All right. So let's go ahead. We're going to play this game real quick, and I think that I just have to stop sharing for a second so that I can change the screen again. And let me
Do
find...
you have to download it, or?
What's that?
Do you have to download the game, or?
Nope.
Okay.
On this, you remember this from
What?
today?
Yeah.
All right. So I believe on the left-hand side of your screen, when you hover over it, there is a pen. It looks like a banana. It's a pen with wings or
A mustache.
mustache. Okay. So we're going to be using that shortly, but I don't know that you can use that for this activity, okay? So here, this is an atom of lithium, and so you didn't get to do this one, but it says on the top, explore, build me. Now we're doing the questions. So this is one atom of lithium. Here is our inverted box from the UK, from the periodic table. We have an atomic number and atomic mass. You can see that the nucleus has already been made for us. We have 3 protons and 4 neutrons. But how many electrons should it have?
7.
3.
4.
Oh, I got 3 different answers. Why don't you type your answer in the chat box, and I'll take the most answered answer. The most common answer. Okay, again, we're looking for electrons.
Oh, electrons? Oh.
Okay, there we go. Electrons for most are going to be the same as protons. So let me try 3 electrons.
What is that noise?
I'm thinking that could be Gavin, so let me... Oh, you know what? Look at it's got 6. I didn't do that.
Hmm?
Okay, we're going to try another one. You know what happened is I changed the number here. Your house is ringing. Could you turn the mic off, please? Thank you. All right. So here we're going to try another one, and I can see you're typing the chat box. So real quick, let me look at something. Trying to figure out how to get back there.
Joel's back.
Okay, I think when you all are, it's funny, it's like when you're typing out in the regular, on regular Google Plus, it's not in the same chat box as if you're doing it right there on the screen. But that's fine,
Yeah.
We'll figure it out. That's what that beep is, that somebody had a text or something. Okay, So here we go. We're going to do another one. We'll do just a couple. I'm going to wait till we get a normal one. Okay, so here's carbon. And we have our atomic number and our atomic mass. The question says, how many electrons belong in the atom?
6.
6.
Okay, so we'll type in 6. Check. And you're right. This should be our atom of carbon. All right, we're going to try another one. Good. Here, I'm glad it doesn't say electrons again. Here we have 5 protons and 5 electrons in one atom of boron, so we know it's neutral, but how many neutrons should we have?
6.
6.
Okay, big math, huh? All right, so we take 11 minus 5. Let's see if 6 is right. That's correct. Okay, and so there we have our model. Let's try one more. No, not that one. That's too easy. Okay, that's a harder one. All right, aluminum obviously is a much bigger atom. Do you know what family it belongs to?
Metal.
Mm-hmm. Specific kind of metal?
Transition metals.
Good, that's exactly right, transition metal. All right, so it says that we have 13 protons, 14 neutrons, and 13 electrons. Harder question. What's the mass number of one atom of aluminum?
27.
Yeah, I wish they didn't even put it here because you still could calculate it, right?
Yes.
If I asked you that without showing you this box from the periodic table, how would we have known the mass number or atomic mass of this element?
The bottom of the screen shows the number of electrons.
Right, but the electrons aren't in the nucleus.
Or protons.
Right, protons.
So you add that to 13, just 27.
13 and 14, right? The protons and neutrons. Okay. All right, good. That's exactly right. All right. So I have a couple more games and stuff for us to play. So I'm going to go ahead and go back to our presentation. You guys doing okay?
Yeah.
Good. I won't keep you long. We got a couple games and a couple more things to go over, okay?
Okay.
I know you saw me enough today. Okay, so we should be here. You guys said that the boxes tell us on the periodic table. Oh, can't see that very well. Let me make it a little smaller. Oops. All right, this is where I think you can write on the screen. So if you use the little pen tool, maybe, I think, Colin, if you're on your phone, it might be really hard. You can try it.
I don't have a pen tool.
Okay. All right, if you scroll over to the left on your screen, I don't know about, again, if you're on the tablet, and then it should pull open those little menus, like where we put on our mustaches and our hats. And again, if you want to turn off the mic for a minute so you can see the screen.
So the pencil with the mustache?
Yes, the mustache pencil. And so if you guys will turn off your mic, because when you make noise, then this is going to disappear because it's going to put you up there. So if you will click the pen tool, you should be able to fill them out. Jalen, do you want to see if you want to do, which one do you want to do? Oh, I'm sorry. I turned, just write on the one that you want to.
It won't seem to let me. It says the user hasn't ran it. Oh, never mind.
I'm really tired of getting kicked out of this.
Okay, can you use it now?
Yeah.
Okay, but Jalen, you got the Okay. It's not letting you use it? No.
Wait, oh, we're not letting you use what?
We're trying to use the drawing tool.
Oh yeah, it's not available for my computer. It says it's not usable in my platform.
There, I don't know where to scroll. I don't actually see anything.
Okay.
There should be a bunch of dots there, and you can just download it if not.
Oh, wait.
It's all right. So let's go ahead and figure it out. You like the name of the word that we made out of the elements? Sorry. Sorry. Okay. So we have bacon, elemental bacon. All right. So let's
Bacon.
look at the barium. Okay. So how many protons? If you guys will type, how many protons in one atom of bacon? I mean barium. Everybody look at everybody's answers. Okay, 56. Good. So how many neutrons would there be? Okay, 81, very good. And then electrons, guys, should be the same as what?
The protons.
Yep, should be the same as the protons. Very good. Okay, let's look at cobalt. How many protons and electrons should it have?
27.
27, very good. That's our atomic number. You can see here it's in a different order again, right? So that's why I was trying to let you know, if you just kind of get used to the pattern, that the smaller number is going to be the atomic number and the larger is going to be the atomic mass. All right, and so, I'm sorry, how about for cobalt? How about the neutrons, please?
2.
Very good, Colin, 32. He's on it, and I bet you know what element I'm going to ask for next.
No idea.
It's been a long day. Okay, so nitrogen has how many protons and electrons?
7.
7.
7, and neutrons?
7.
7, lucky 7. Hey, do you know what you do with a dead chemist?
No.
You
No.
bury them.
No.
Oh.
Bum. Okay. All right. So I'm going to go back to the, let's see, this presentation. Let's try compounds real quick. Okay, we got just 2 more things to go over, okay? And then we're done. Or we're going to play a game, okay? So all of these atoms that we've been talking about, the elements from the periodic table, we're going to look next week at the trends, like which ones are going to come together to form compounds. But essentially, for right now, you just need to be able to know that when they come together, they go through a chemical change, which is a chemical reaction, and that forms a new substance with totally new properties that are bonded together. Again, I like to compare it to superglue. They're not coming apart unless there's a significant amount of energy used to rip them apart. But they're going to be pure because they're going to have this chemical formula that's going to tell us the number, the types of elements, and how many of each atom there are. It's going to be the same all the way through. All right, so these are some of our basic ones. CO2, does anybody remember what that is?
Carbon dioxide.
Very good. It's funny when I say carbon dioxide in class, some people have a hard time going the other way, allowing us to remember it's CO2, but that's good. And O3, that is...
Carbon monoxide.
No,
Ozone.
Ozone, good. You can read it. I couldn't barely read it myself. So that is the ozone. So when they talk about ozone as being depleted, that's the gas that's in the ozone. And then water, of course, we know that in N2O,
Nitrous oxide.
Nitrous oxide.
Nitrous oxide. So when you're watching all of these shows and they're pumping
With
that
the
in.
fast cars.
Yep. And so that's what helps them go. And what happens is it burns in the engine and it expands when it burns. So it creates greater pressure, which makes the car go faster. And so I know you know that H2O is water. So what is H2O for?
Water? No.
H-
No.
What is
Purified water?
I have
Gatorade.
no idea.
Gatorade.
It's for taking a shower and brushing your teeth
Fun.
and, you know,
Soap.
swimming. H2O.
Fluoride.
H2O for brushing your teeth. Take
Water.
Toothpaste?
Potassium.
Okay, one more time. What is H2O?
Baking soda.
Dude.
Chlorine.
No.
Phosphorate.
No, think about it. What is H2O for? It's for brushing your teeth. And
It's
taking a
yeah,
shower.
I get it.
It's just water.
I
Oh!
get that.
Okay.
I thought you meant to put a 4 on the end of the H2O.
I did. It's a joke. Oh, ha, ha. Okay. So you can get somebody else with that tomorrow, because obviously you can probably deliver it better than I do. All right. So let's look at these real quick, and then we'll play our game. Okay? So maybe we can take one at a time so you can each have a chance to answer. Who wants to go first?
I just got that joke.
Oh my god.
Miss Carey, I have to go. I'm about to eat.
Okay.
Never
All right,
mind.
Emmanuel, you're smart enough. Thanks for coming.
No, I'll stay instead.
Okay. All right. So who wants to do the first one?
No, I don't. Wait, yes, I do.
I guess I'll do it.
So, Emmanuel, I just want to know what 3 elements are in that first compound and how many of each one are there?
There's 6 carbon, 12 hydrogen, and 6 oxygen.
Very good. That's exactly right. So it's made of 3 elements, carbon, hydrogen, and oxygen. And there's a total of how many atoms in one molecule?
24.
24. Very good. Okay. So who's going to do the next one?
I'll do it.
Cynthia.
Okay, Cynthia?
Okay. I think this is right. A hydrogen, nitrogen, and oxygen.
Very good. And how many of each?
There's 3 oxygen.
Right. And the other ones have no number, which is called a subscript, okay, for tomorrow's quiz. So it should be a total of what?
0, 1. I don't know, 3.
Okay, 3. How many hydrogen?
1.
1. Do I see y'all helping her? 3 and 1. And
I'm not helping at all.
Hydrogen.
1.
1. 3, 1, and 1. Very good. So it's a total of 5. Yeah. So make sure you're looking at the questions because sometimes they get tricky. There's 5 atoms in one molecule, but there's 3 elements. Okay? All right. So let's see. Galen or Gavin, who wants to do the CaCl2?
Jalen does.
Jalen does, I guess.
Okay.
Okay.
Slow. Oh, Gavin, you don't want to do it? Got it, table.
What?
Because one of you might need it for the last. Okay, looks like Jalen has one. So, Gavin, why don't you do the CaCl2?
I know the first one is carbon, isn't it? Or calcium, maybe?
It's calcium.
Ooh. And then,
Yeah, do you remember?
chlorine.
Uh-huh.
Okay, so there's 1 calcium and 2 chlorine and 3 atoms.
Very good. That's exactly right. And Jalen, the next one's yours.
There are 3 hydrogen, 1 boron, and 3 oxygen. So that equals 7 atoms.
Right, in one molecule of that substance. Very good. That's exactly right. Y'all are doing great. All right, so the last slide I have for you is the link for the game. So let me go ahead and stop that again, and we'll put the game on. Oh, thanks. Somebody
Who did
was
that?
using the pen. I don't know how to
I
erase it.
didn't do it.
Oh, I must have done it. Oh, wow. How do I get this off?
Oh, I
Quit
guess.
drawing!
How do I get this off? Okay. Oh, there.
What's floating over my mouth?
That was me.
Blah, 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 blah. Okay. All right, I'm going to go to the
Oh,
other
wait, look,
thing.
hold on.
We can play with that in just a second. All right, that was here and here.
Hey. Did you guys see the laughter?
Whoops. Got to find the right window. All right. So here is our last. Oh, that's not it. That's the wrong thing. We skipped this. We skipped this. We don't Does anybody know which atom this might be?
1, 2, 6 protons. That would be
The MG.
Carbon.
that would be carbon.
Carbon. Very good.
You got that right. You got that right.
Okay. This wants to know if it's normal or if it's an ion.
I know what it is.
Normal?
It's normal.
Normal.
Very good. This isn't the game we were going to do. Does anybody?
That was not me.
Okay, we're almost done, guys. Come on. Do you know what element this is? And I'll put the right game on.
Helium.
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 Yeah, we did it.
Okay. Let me pull up the other game
That's normal.
because I think this game will be fun.
Nice bet, Cynthia. What are you doing, Gavin?
I'm not doing anything.
Oh, you know what? I'm going to have to.
Miss Carey, do you want to try another one of your jokes?
Do you know why carbon married hydrogen?
No.
Because they bonded well from the minute they met. Oh.
I hope I make you feel better.
All right, I'll give you one more, okay? So a neutron walks into a restaurant and orders a couple of sodas, and she's about to leave, and she asks the waiter, well, how much do I owe? And the waiter says, oh, for you, no charge. Oh, you have me on screen, don't you? Okay, wait, I can't find that screen.
It's the effect.
There we are.
The Google
Okay.
effect. You just like
So
when
let
you
me
use
go
that.
ahead and show you the. That's funny. I was reading my jokes. All right, here we go. All right, so you can see the game.
No. Oh, there it
I
is.
hear some cricket.
I wanted to play one.
Or we're just going to play one player, okay?
Okay.
So, because we'll let you guys pick different topics.
Vocabulary 500.
Okay, so all right, so you're going first. This is a high school level game. You might want to pick less than 500. If we don't know it, we're just gonna move on. But do you want to try
100 then.
100? Okay. Blank are elements that are good conductors of heat and electricity. Now.
Metals are elements that are good conductors of heat and electricity.
Metals. Okay, that is correct. Very good. Okay, Cynthia, you should have gone first because ladies go first. So which one do you want to do?
That's why Emmanuel went first.
Oh.
That's not nice.
That was mean.
I'm the
Um,
one with the crown and the mustache.
the periodic table, 500.
Okay, you sure 500? It's a high school game.
Sure.
Okay. Who developed the first periodic table?
Mendeleev.
Was that Cynthia?
No.
Yeah, that was me.
All right.
No, it wasn't.
Very good. All right. Is Gavin still there?
Yeah.
Would you like to choose?
Sure.
What about Jolene? She's the next one.
Okay, if we can get her to come out of her shell.
Jolene.
Yes.
Come out.
Oh, the periodic table for 300?
Okay. How many periods are on the periodic table?
7?
Very good. Awesome. I didn't know that without looking at it. Good job. All right. So is Gavin next?
I guess.
Okay, I can't see your pictures while I'm looking at the game, so.
All right.
Hey, when I move the game like this, does it move on your screen?
A little bit.
Okay. I didn't know. All right, Gavin.
The atom 300.
All right. Each energy level of an atom has a maximum number of blank it can hold.
Electrons or electron shells.
Very good. That's exactly right.
Yeah.
Oh,
Who
hello.
is it?
No, that was me. I clicked it.
All right, Jalen, I think it's your turn.
My turn? Oh,
Periodic table 100.
Okay.
Cha-ching.
Horizontal rows of the periodic table are called what? Did you say groups?
I guess. Wait, what side? Okay, you can. Okay, which side is vertical? Is it like going up and down?
Horizontal is like the horizon, like when you go to see the sunset or the sunrise.
It's left and right that's horizontal.
Oh, well then, period.
Very good. Okay, who do we have? Is it Cynthia's turn again?
It's my turn.
Okay.
Oh,
Let's
yeah,
go with the
'cause you went
nucleus for.
I'll let you guys do one more, and then we'll just make sure no one has any questions.
Alright, let's go with the nucleus for 400.
Okay. The nucleus has an overall what kind of charge?
A positive charge.
Neutral charge. No charge.
All right, Cynthia.
Types of elements, 300.
Blank are highly reactive elements found in group 17. It's the family before the noble gases.
I'm searching the periodic table.
Oh, okay.
Hurry up. Non-metals or something?
or something.
Oh, thank you for sharing that, Jolene. No, it's the ones right to the left. Do you want me to put non-metals?
Is that to the left?
No.
No, it's the halogens. The halogens are the family right there. Okay. So next we have Gavin. Are you still there with us?
Mm-hmm.
Okay. Which one would you like?
The atom for 500.
Blank are atoms of the same element with different number of neutrons. It's one of your vocabulary words, but we haven't talked about it yet.
Ions.
No, it's isotopes. All right, so isotopes, we'll talk about those next. They're just neutrons, and where are the neutrons at?
In the nucleus.
Right, so these atoms either have skinny nuclei or fat nuclei. That's the only difference. And they're considered an isotope, which is a different type of what's regularly on the periodic table. Okay? All right, we got a couple more. Jalen and Jolene.
Oh, he's playing the Godzilla music.
Whose turn is it?
I think Jalen. Ready? Okay. A blank is an atom that has a net electric charge from gaining or losing an electron. No, this is one of those special atoms that doesn't, that has a charge. You said if it's positive or negative.
Wait, so it has a charge?
It has a charge, What did Gavin just say?
Iron?
I didn't hear you. I can't hear you over the sound effects.
Stop.
Oh, okay. There you go. That's correct. Good job.
All right. Miss Carrier, next time before you type in the answer, let me do something. Like before you press enter.
Okay. Jolene, it is your question, and then that'll be our last question, except for your question.
The periodic table is 200.
Okay? Vertical columns of the periodic table
are called groups.
Okay, what did you want to do, Emmanuel?
Alright, type in the question yet? Type in the question.
You want me to?
No, type in the answer.
Okay.
Now type in answer.
Got it? All right, you guys earn 1,900 points. 1,900 points, very good.
Does anyone want to try a game with me? I found on the App Store thing here. Maybe like after it's done. It's called Warlight. You could just go to my apps and add an app. It's just called Warlight. Strategic Games of War. And my monocle and frown.
Nah, I've got enough of those.
Okay. So, do you guys have any questions for me?
Not really.
I want to learn how to draw.
It doesn't work on my computer.
Yeah.
Well, it might work if we're not in the Google Live Hangout. It might be because we are live, because it's being broadcast on our YouTube channel. So, what I would recommend...
Jalen was able to do it.
Yeah. But, Gavin, you're on your tablet, you said, right? So you do have to click and download that part of the app.
But it works for me. Good job, Jalen. I'll give you some props for that.
Are all the words on our vocabulary
going to... No, not all of them will be on it. Unfortunately, I can't tell you which ones are not going to be on it. The ones that we have done the most will be on it.
Okay.
So make sure, I think you'll be all right. I think it's not difficult, but especially since we're here tonight, you should do better than everyone else. And make sure you're familiar with the box from the periodic table. Okay.
So are we done here?
Yes, sir. But listen, thank you so much for being here. Again, I'm going to tell everyone when we're done with the program, you'll get extra credit for participating. We're going to do 3 weeks. So this week was on atoms in the periodic table. Same time next week we'll do atoms, compounds, and ethers. And then the last week we're going to do chemical reactions and equations and a review for the test.
Okay, are we gonna do this? Are we gonna do this like more often than just those 3 weeks, or?
Yeah, typically I would do it the day before a test.
Okay.
But I wouldn't do it like every week, okay? So that way you can jump in right before a test and we can do a general review to help you and go over questions that you have specifically. Okay?
Okay.
All right, so what I was going to tell you is I am going to log off because so we can stop recording, but because you have each other's links, you can see each other, you can call each other and do this anytime. Just please be appropriate.
Yeah, but hey guys, do you guys want to try that game out with me?
All right, and have fun with it because technology is awesome. It's going to be changing, and maybe one day you'll do this for work. You'll talk to people across, you know, oceans.
Okay.
Whatever you endeavor. Okay? So I'm going to sign off. Thanks again. And I will see you guys.
Nice. Thanks for having you.
You're welcome. Good night.